So here you are given the problem like this. A steel manufacturing company wishes to know whether the tensile strength of the steel wire has an overall average of 120 pounds. So we have to check whether or test whether the overall average of tensile tensile strength is 120 pounds. That means we have to test the null hypothesis that H naught mu is equal to 120, and we are not given any keywords like less than, greater than, so on. So we can take the alternative hypothesis as H1 mu not equal to 120. Now what all the data we are given? A sample of 25 units of steel wire. So a sample of 25 units, that means n is equal to 25, which is less than 30. So we are having small samples. So sample size is small. Of steel wire produced by the company yields a mean strength of 110 pounds. So this yields a mean strength of 110 pounds. So this sample have an average strength of 110 pounds. That means X bar is 110. Okay. And a variance of 144 pounds. So variance, you are given sample, variance of the sample. That is, you are given variance which is 144. So what is standard deviation? S root 144. So which is equal to 12. Okay. Now we have to test whether our mean tensile strength is 120 or not. So mu naught is 120. So here our n is less than 30 and population standard deviation sigma unknown, because we are given sample standard deviation. Sample standard deviation means population standard deviation is unknown. In that case, what will be our test statistic? So when n less than 30, we are having two conditions. If n less than 30, sigma naught, and n less than 30, sigma unknown. So here this is our case, n less than 30 and sigma is unknown. In that case, our test statistic is t equal to x bar minus mu naught divided by s by root n. So this is our test statistic. Here we are having the test statistic t. T is our test statistic, and this follows with a t distribution with the n minus 1 degrees of freedom. So here we are doing t test instead of z test. So t test is used when your sample size is small and sigma unknown. So our test statistic is t is equal to x bar minus mu naught divided by s by root n. This follows t with n minus 1 degrees of freedom. Now let us substitute the values. X bar is equal to 110 minus mu naught is 120 divided by s is 12 by root 25. Okay, so which is equal to 110 minus 120 minus 10 divided by 12 by 5. So the answer is, what will be the value of test statistic then? So this will be 4.167. Okay, minus 4.167. Now we are given alpha as 0.05. So I already told you that if you are not given the value of alpha, you can take it as 0.05. So here you are given alpha as 0.05. Okay, alpha as 0.05. And since h1 mu not equal to 120, our critical region. So this is our alternative hypothesis, h1 mu not equal to mu naught. So what will be our critical region? Modulus t greater than or equal to t alpha by 2. So here we are having t test. Okay, so this will be our critical region. So the critical region is is modulus T greater than or equal to T alpha by 2. Modulus T greater than or equal to T alpha by 2 means our region of rejection will be in two sides. That is, whenever our value of test statistic is less than minus T alpha by 2 or greater than T alpha by 2, we reject the null hypothesis. So this is a two-tailed test. If you are given modulus T or modulus Z, that means you are having two-tailed test. So corresponding to this, we have to find the value of T alpha by 2. And what is our N? N is 25. N is 25. And we are having this follows a T with n minus 1 degrees of freedom, means this follows T with 25 minus 1 degrees of freedom. That is T with 24 degrees of freedom. So in the T table, corresponding to 24 degrees of freedom and alpha equal to 0.05, we have to find the value of T. Okay, that is our T alpha by 2. So let's see. So this is a T table. So here T table, we are having the value of alpha. One is bolded and one is not bolded. So in the brackets, the values in the brackets are used for one tail test, and in the bold letter is used for two tail test. Okay, which is written at the bottom of the page. Okay, now we are having two tail test. So we can use the bold values for two tail test. So alpha is 0.05 and our n is 24. So n 24. So corresponding to this value, our T alpha by 2 value is 2.064. So T alpha by 2 is 2.064. Now let us compare. So modulus T means when we take modulus to this value, negative will not be there. So this will be 4.167, which is obviously greater than 2.064. That is T alpha by 2. That means our critical region is modulus T greater than or equal to T alpha by 2, which is satisfied over here. That means value of T lies in the critical region. You can see that minus 4.167. Our T alpha by 2 is 2.064. So this is minus 2.064. When you are having minus 4.167, the value will lie here in this region. So value of test statistic falls in the critical region. Hence we reject H naught. Since the value of test statistic falls in the critical region, we reject the null hypothesis. Rejecting the null hypothesis means we are accepting our alternative hypothesis. Alternative hypothesis is that the average tensile strength is not 120. So this hypothesis may be accepted. So you can write the conclusion that the tensile strength of the steel wire has not an average, has not an overall average of 120 pounds. Okay, thank you.